Welcome back. This is another part 2 video of topic 3. And we're going to take a look at evaluating expressions in this video, or start with that. When you evaluate expressions, we are using something called PEMDAS. Please excuse my dear Aunt Sally. It tells you in what order you need to deal with the operations. So parentheses is always first. Then you have exponents, multiplication and division, addition and subtraction. Now the key to also is, while these are the order, if you have more than one parenthesis or more than one multiplication division, what you're going to do is you're going to concentrate on moving from the left to the right. Especially when you are at multiplication division, these two get grouped together, and addition subtraction. You're going to concentrate on left to right. All right, so for instance, one of the problems you could look at is 8 plus 6 minus 2 times 2 minus 3 squared. Okay? When you do this problem, there are no parentheses, but there is an exponent. It's way down here. So what we're going to do is we keep everything else, and now we evaluate 3 squared. 3 squared means 3 times 3, so that's 9. And then we start at the beginning again. Do we have any parentheses? Do we have any exponents? Do we have any multiplication? And there we do. So now we're going to keep the 8 plus 6 minus, but now 2 times 2 is 4, and then we have the minus 9. Again, you're going to move left to right, and we know we're at adding and subtracting. So we're going to do 8 plus 6, which is 14. Then 14 minus 4, which is 10. And then 10 minus 9 is 1. Okay. The next thing we're going to look at is expressions. Now we will be coming back to PEMDAS because many of our expressions we're going to do something called plug it in, the old Glade commercial. And when you plug it in and you have to evaluate or solve, you're again going to use PEMDAS. So we'll come back to that in just a minute with another problem. All right, so we looked at expressions. An expression means there is no equal sign. You must have a number and an operation to be an expression. For instance, we looked at something like this: 6 more than a number C. And what we had to do was we had to write this in math terms. So you can see this is a 6. Oh, and they said more than a number C. Okay. We know the number is going to be called C. And then more than means add. So you've already made your expression just by using the words. So the expression is 6 plus C. In this expression, the letter is your variable. And this 6, which is not going to be changing, 6 is 6, is known as your constant. Another important piece of information is this expression has 1 term and 2 terms. A term must be separated by a plus or a minus sign. So in this case, there are 2 terms. All right. Another one that we dealt with, and this is important, 2.5, 2 5/10 less than a number, D. And I'm running out of room. Okay. So again, we have this 2.5. We have a number D, and we have less than. Well, less than is a takeaway, is a minus situation, but this is a tricky one. Anytime you have a less than, they actually switch these, okay? And you can think about it, is 2.5 bigger than the number D, or is D bigger than the number? And we've had ones that we started with that had a number on both sides, so they could answer that. But the 2.5 is smaller than the number D. So we're going to start with our number D and take away from it the 2.5. Okay, D is your variable. 2 5/10 is your constant. And there is 1 term and 2 terms. All right, here is another one that we worked on. So twice a number, K, plus the difference of S minus 2. Okay, so when we're looking at this, twice, we know means 2 times. We have a number K, so that's going to be a K, plus, all right, this is difference. Well, difference means to subtract, okay? The difference of S minus 2. So when we put that together, we have 2, and we actually don't need to show the multiplying, and I'll tell you about that in just a minute. 2K plus the difference, that means the whole answer, so I'm going to put parentheses because it wants the whole answer of S minus 2. And that would be your expression. Now, as we talked about in the last example, or the last couple of examples, S is a variable and K is a variable. So your variables are S and K. Your constant is going to be this 2 down here. But your coefficient is any time you have a variable and a number. So this term has your coefficient in it. The coefficient is the number, but it means 2 times the variable. And that's why we didn't actually need to write a dot, because it always means you're multiplying your coefficient and your variable. Amount of terms, there's 1, 2, and 3. So this has 3 terms. Alrighty. This is also going to be covered again in topic 4, where we're going to do more with the algebra. This is considered a pre-algebra. Some of our students will be going right into algebra, some will be going into pre-algebra, and some will be going into 7th grade math. And so they get a taste of algebra now. All right, so what can we do with our expressions? Well, for instance, we could take d squared divided by 2c minus b plus 3a. So this is an expression, okay? But what I'm going to ask, or what has been asked, is that we would take an a value of 1/3, a b value of 9, a c value of 5, and a d value of 10. And what we're going to do is we're going to plug it in. And again, the Glade commercial, plug it in, and many of the kids will sing it for you now. So, in place of the D, I am now going to put this 10 in place of the D. So now I have 10 squared. Okay. I'm going to keep the dividing sign. I'm going to keep the 2, but in place of the C, I'm going to put in 5. Now again, whenever you have a number in front of a variable, this is a coefficient, this means these are going to be multiplied. So I'm going to take 2 times my C value, which is 5, minus my B value, well, my B value is 9, plus 3, and in place of the A, I'm going to plug in the 1/3. Again, it means we're going to multiply the coefficient times the variable, so 3 times 1/3. You can show it with a dot, or you can show it with a parenthesis. We're trying not to use the X any longer because of variables, and now X is also a variable. All right, so when we go through this, we're using PEMDAS. Please excuse my dear Aunt Sally. We want to start with parentheses. So this could be considered parentheses or multiplication, doesn't really matter. We're going to take it as multiplication right now. So let's start with our exponents. 10 squared, so that means 10 times 10 is 100. All right, and I'm going just to keep everything else for now. I always tell the students to show all their work, because if they do and they make a mistake, I give partial credit. So as long as I can see what they've done, I can go through and grade each line. All right, the next thing then is multiplication and division, but we have to go left to right. So I'm going to start here. 100 divided by 2 is 50. I still have times 5, minus 9, plus 3 and 1/3. Okay. Now 50 times 5 is 250. 5 times 5 is 25, stick on a 0, minus 9, plus, I'm going to go ahead and work this out now. The students should know from last year that we add a 1 under this, and that 3 times 1 is 3, and 1 times 3 is 3, but 3 divided by 3 we know is 1. 250 minus 9 is 241, plus 1, so 242. Okay, so again, we're using PEMDAS even though we are dealing with an expression, and what they would have been asked to do is evaluate. So I'm going to go ahead and stop this video. I will load a third part with the last little bit of what we were doing in this topic.